Today's lesson is going to focus on percentage yield of a chemical reaction. The percent yield looks at two values that we use when we are carrying out chemical reactions. So there is an actual yield and a theoretical yield, and you need to know the difference between these two terms. So when you have a chemical equation or a chemical reaction, and you are calculating the amount of product using stoichiometry, this is what we refer to as the theoretical yield. So the theoretical yield is how much of that product should be obtained if everything happened perfectly in your chemical reaction. So no errors, no loss of product. Every single molecule or atom was converted into that product. In contrast, when you carry out an experiment in the lab, things don't always happen perfectly. Sometimes you get pretty close, but lots of times things aren't perfect. And so when you carry out an experiment, the amount of product that you actually obtain in your reaction or in your experiment is what we refer to as the actual yield. This is also sometimes called the experimental yield. So I'll use both terms interchangeably. Lots of times I just write actual yield because it's shorter. You usually will have differences in the two yields. So theoretical yield, again, is through calculation. Actual yield is what you collect in a lab experiment. And typically the difference in these yield values deals with technique, okay? So experimental technique or poor collection of the product that you are trying to obtain, those two kind of go hand in hand. So you do have to learn good lab techniques and you have to practice collecting product in order to do it well. Sometimes it could be based on the actual procedure that you are using. So an experimental design, this is usually not our issue unless we are doing a design your own lab. But if you're following numbered steps, oftentimes you just follow the steps and rely on somebody else to design the experiment for you. And sometimes, but not often, we have impure reactants. So the reactants that we use perhaps have contaminants in them to some degree. This is very rare, but it can happen from time to time. The reactants that we use in the lab are of a high quality grade. So when we calculate the percent yield of a reaction, it's a very simple calculation to do. We take the actual yield and we divide it by the theoretical yield. So this actual yield, again, is what we obtain in a lab. The theoretical yield is what we would have calculated using stoichiometry. And the thing to know that when we're talking about percent yields, it is always for a product, okay? You would never speak about a percent yield for a reactant. It doesn't make any sense. The term yield means, makes. So how much, is this reaction making? And the percentage that you're calculating is really a percentage value based on how much product you make. So we expect the value to be close to 100%. Okay, so ideally, in a perfect world, whatever your theoretical yield is, your actual yield should be exactly the same. And when you divide those out, you get a value of 1 times 100 should be 100%. But what we know happens is that oftentimes this actual yield will either be higher or lower than the theoretical yield. And then we, assess errors accordingly. So just a few key points about the concept of percent yield. A reminder, right? Percent yield, it measures the amount of product, okay, that a reaction can make. The higher the yield, the better the outcome. But be careful here. We mean the higher the yield to 100%, okay? You sometimes can have yields over 100, okay? That doesn't mean it's better. So over 100% is not better. It just means that your actual yield is greater than your theoretical, which can happen. So we want as close to 100% as possible. Anything above or below is telling you that you're not collecting as much product as you should be. The actual yield is either going to be given to you in a question. Okay, so if you're doing calculations on percent yield, from a worksheet or textbook, and you're not carrying out the experiment, then you cannot obtain an actual yield yourself. So you either obtain it through a lab experiment, but if you're not doing a lab experiment, we have to give it to you. Okay, so you have to be given that value. So it'll be an extra mass value that is in the question. And then a reminder that the theoretical yield is obtained through calculations. Now I have 3-step stoichiometry here, but it could be 4-step if you have a limiting reactant question. Okay, so it'll be through our either 3 or 4-step stoichiometry process. Let's try an example of a percent yield question. They're not that hard. They just use stoichiometry and then that simple calculation at the end. But sometimes they can be a bit confusing because they give you some extra information and we have to understand what it is that they are providing. So here is a reaction for the decomposition of calcium carbonate. And then it says, what is the percent yield for the amount of CaO? Okay, so this is important because there are 2 products. I know my reaction is kind of split, but there's a product there of CaO. There's a product of CO2. So we have to be specific as to which product. If 24.8 grams of calcium carbonate, so we can write that in here. So we are starting with 24.8 grams of it, is heated to give 13.1 grams of calcium oxide. And this is where you have to be careful because they're giving me a mass of calcium oxide. I'm going to write it down, 13.1 grams. Oops, not able to write that 1 for some reason. There we go. So 13.1 grams of calcium oxide. And I have to calculate percent yield. So I actually have to calculate the theoretical yield of calcium oxide that I should be obtaining if this reaction happened perfectly. So what is this 13.1 then that they gave us? So you got to understand that you're going to be dealing with 2 different masses of a product because they have to give you the actual yield. Okay, so this value that is given to you for the product is the actual yield that they obtained in the experiment. So once we understand that the actual yield value is going to be given to us, we can then go through and calculate the theoretical yield of our product. And remember, we do this using 3-step stoichiometry or 4-step if it's a limiting reactant. Now, the nice thing here is we don't have a limiting reactant question. We just have 1 reactant. So we're just going to start with our 3 steps. We're going to figure out the moles of my known substance, which is calcium carbonate. And we're going to calculate mass over molar mass. And we'll set it up 24.8 grams. And we divide by the molar mass of calcium carbonate, which works out to be 100.09 grams per mole. We figure out our number of moles, and we're going to get 0.24, and then a bunch of 7s. So I'm going to round here to 5 decimal places. Now, we're moving from calcium carbonate over to calcium oxide, and the nice thing is that everything is balanced. So when your reaction is balanced and your mole ratio is 1:1, in step 2, we can just say, due to a 1:1 ratio, the moles of calcium oxide will equal the moles of calcium carbonate, and then you can just sub in the mole value, which is 0.24778. We're going to convert this into a mass. So we need to know the mass of calcium oxide because I have to know the theoretical yield. So we're going to take moles times molar mass. We have 0.24778 moles. And we're going to multiply that by a molar mass of 56.08 for my calcium oxide. And when I do this, I get a final mass or a theoretical yield of 13.9 grams. So again, this is not new. We're just calling it something different. You've been calculating masses for the last little while with these lessons, but this is now the theoretical yield here that we have calculated. Okay, so theoretical short form yield. Now what we'll do is calculate the percent yield of our reaction. So always write down your formula. So percent yield is equal to your actual divided by your theoretical yield times 100%. And remember, we know this actual yield. They gave it to us above because they had to. You're not actually calculating the, or you're not carrying out the reaction yourself, so they got to give you how much was obtained. We compare this to the theoretical, so how much should have been obtained. It's pretty close. And we're going to multiply by 100. We're going to divide. We have 3 sig figs in each mass value. And when we multiply by 100%, we get a percent yield of 94.2%. Here's an example that you can try on your own. Here are the answers for the theoretical yield and the percent yield. So give us a try and hopefully you can match the answers.